Here, let me illustrate the store and forward effect to the end-to-end delay. So consider this scenario. The source is over here. Okay, user typing up things and generating these small packets, 1, 2, 3. One router here in the middle and receiver on the other side. And each packet here the user is generating is L bits long, and the link bandwidth is RBPS. So you see, to send this big packet over the link at this speed, this is the amount of time that's required. And on a packet switch network, we need to store the packet entirely before forwarding. So entire packet needs to arrive at the router before it can be transmitted further. The end-to-end delay will be what? 1L divided by R for this hopping. Because this guy, to send it out, it requires L divided by R. This router here receiving it waits until O is received, and then what? Send it out again. That's another L divided by R. So if L is 7.5 megabits per second, R is 1.5. You see, each hop, 5 seconds. 2 hops, in this case, how long? 10 seconds. 3 hops, the longer, the more hops you have, the delay of sending the packets longer. This is different from circuit switch network. Bits can be streamlined. Okay, there's no need to store a bunch of bits first before forwarding it. Okay, that is saying that each bit arriving here gets out quickly, so there's no hopping. It's just the propagation delay and the transmission delay, L divided by R, from the first hop. This slide is to illustrate congestion. The scenario is A and B, 2 users generating packets. A generating blue packets. A generating green packets and B here generating blue packets. And you see these packets are generated as user A and user B are typing things up spontaneously. So green and blue, they will kind of bunch up or multiplex in a random order. Okay. Unlike in TDM, time division multiplexing, everything goes rotating rhythmic. And this, okay, having some sort of spontaneous behavior in it is statistical multiplexing. Okay, so on packet switch network or on the data network internet, yeah, packet kind of, multiplex to each other randomly, spontaneously, depending on how they are generated. Now, let me draw your attention here. The router. You see packets in case the outgoing link bandwidth small. And incoming link here, this is 100 megabits per second Ethernet. This is only 1.5 going out. Chances very high, A and B, if both of them actively generating lots of packets, yeah, the packets will have to wait here in the queue before they get the link queues. And if there's not enough space here for the queue, the next one, the green one coming here, will need to be dropped. But there's no memory space to hold. And those packets waiting in the queue, yeah, it depends on how long the queue is as they comes in to the router. The queuing delay can vary. It can be a little uncertain. Okay. But transmission delay, the time it takes to go on this link is always the packet size divided by what? 1.5 megabits per second. And we use the full link bandwidth. So transmission delay here is very easy to get.